So I think it worked. If so, everything's working and this is all good. Let me load up the thing, make sure that everything's fine, and then we can get started. And do look like I'm live. That's a good thing. Oh yeah. Oh, thanks. Alright. Well, I'm gonna get myself started here. Today I'm making a thing. Making a piece to fix my fridge. So this is an ice dispenser, and I guess this is the piece like that spins inside to like dispense the ice, hence name ice dispenser. So yeah, today I'm going to be making this in Blender so that I can 3D print it and then send it, into the fridge where it will chill out, and I guess into the freezer actually, and it will do the thing. So first thing I'm going to do is take some measurements here, and then we're going to make it. So we got a few circles. We got one there, one on the interior. I got like a spoke. One on the interior is yay big. There's a spoke. It's yay big. Alright. So I'm getting there. So we got half of it. We're always going to mirror it. So whatever I do on one side, it's going to happen on the other. I also need a side profile. So make the side view of it. Just a sketch, doesn't have to be perfect. And then a centerpiece. That centerpiece has a key on both sides. That'll get repeated on the other side. That key goes most of the way up the shaft. Shaft. Alright. I'm ready to take some measurements. Got my handy dandy calipers. Battery's all charged up and ready to go. Alright. So we got 2.5. A 7. A 9. 13. 28. This is easy. 55. Guess we'll call it 56. tacked shaft. 13.5. Interior diameter of the shaft. Tricky one. Glad that I got both halves here. So it makes this possible. I'm gonna say 7.5. Alright. Nice. And what others? So I should be able to deduce that one. About 3. And 3. Looks like this interior one is what, 2.5, yeah. And my notches do have an interesting pattern. So looking at the ones in the back here, I'm gonna have to make those teeth somehow. Could just try gluing this piece back together, but I feel like it would just bust. So that's why we're doing the print. Alright, so I see it now. So it's got a flat and a flat. I don't know how to show that on there, but I got an even space to work with. Looks like they're right off axis from each other. Tilts in. Like 2. Total thickness on that tip is 3. And that length 15. With girth at the base. Eight. All right. Appreciate the music from the pretzel. You always rockin'. Alright, and then the last is going to be the actual ice dispenser chunk, which has a very unique shape. It's got rounded around the outside, tapers off at the base. So I'm just going to kind of draw this from one side view, and then we'll stretch it out later. So total width of the base, 25. The height of that little triangular area, call it 12. How far is that sticking out? That 12, it's coming out about 40. Alright. Total height, we're gonna know off of and then this just goes from the widest point here, call it 12, So what, 3? It's kind of got like a tip to it. 4, we'll call it. All right. What's up, PUBG noob? I am designing a piece for my fridge. So this is the ice dispenser piece. It broke, so I'm gonna design one in Blender here. The first step of the process was just to take some measurements. And so now that I have those, so these are those measurements. Not super crazy. You know, just like a little diagram, enough for myself to go off of so I could design it. And now I'll just start making some primitive shapes inside of Blender. And we'll do this. Nice to have the reference nearby to be able to see it and see what we're doing. So let's get to it. Let's get me out of the way here. Yeah, just remaking that piece. Gotta have it working. So all right. Hooray! Empty canvas Blender, my favorite. All right. So the first thing we're gonna do is we're gonna add a cylinder. And what is that distance there? We have 28. So it looks like I did miss one measurement. It's gonna be our diameter, interior diameter. Get these pieces together. Yeah, if I'd glued this together just so that I could work with it, that probably would have been beneficial. Or at least taped it or something. Alright, so exterior diameter, we've got a 72. Interior diameter. Call it 68. 68 and 72. That makes sense because it's too thick. Alright. Yeah, I have a 3D printer, a couple of them. So I have a resin 3D printer, and I also have a traditional FDM 3D printer, which uses sort of like a hot glue gun, squeezes out the filament. The resin one's really cool. I don't have any prints with me right now, of course. Like, got a bunch on my VR headset. So that's a battery holder for the back here. That one had to be custom mocked up, hold a TB Cast wireless unit, and then also the battery that slides in. So that's a piece that I've 3D printed. Another one that had to be was done. This is for my Oculus Quest. So I've got the 3D printer adapter so that I can have my Vive Deluxe audio headset on here, and then also the same mod. I have like a battery strap, so that I can slide in a battery and, you know, extend my VR experience. So, yeah. But these are super helpful. Otherwise, they come out like black on this view right now. They're very blue, but yeah, they're very, very blue. 68 and 72. And I guess I also need a total interior height. Be 20. All right. Everything is aligning up now. Alright, so now that we got this cylinder here, we're going to make it a certain size. We are going to make it 68. 68 divided by 2 is 34. And the height will be 20. We're going to position this 10 up. We're working in meters right now, but the scale is expensive to own one. Not really. So the 3D printers are pretty inexpensive now. The resin printer that I have is only $150. The printer that I first bought back in 2015 was only $180. That one required a lot of tinkering to get it to work. It was already a different design, Delta printer, which isn't like a traditional 3D printer, and so it took additional work to learn how to work as is, and on top of that, I was just working with a 3D printer for the first time, so it was a nice learning experience. But you know, a few weeks in, I was able to get some prints out, and I've been doing it ever since. So about 6 years now. But it's not super expensive. The material is really inexpensive. 2.2 pounds of material is like $15 to $20 US. So that didn't take a lot. This cylinder could have more facets, so I will have to remake that, but that's okay. That iteration is part of the process. So we're gonna crank this up to 128. That's a smooth boy. Still got the 34 and the 20 and the location 10. So now that is our bottom punch. We'll call it punch bottom, so it groups all the punches. I want to print folks because they always disappear. Forks, yeah. Yeah, forks are definitely a thing. There is a lot of designs out there that are available for free, believe it or not. So I imagine there are definitely forks out there. I can't even spell fork right now. That's hilarious. Oh wow, little excavators, tiny little forklifts. Alright, I gotta get you in on this. So, wind capture. Source. There we go. So fork. So utensils, yeah, there we go. Fork, knife, and spoon. They definitely got them. A fork, a knife, and a spoon. I mean, those are generic models. Those would probably be really hard to print as is. I'd suggest like a very flat model, sort of like these. They're credit card cutlery. There we go. So these credit card prints are a really popular thing. They'll usually be like the size that that index card size, but they'll have like little planes. I've actually got a printable sort of like this dinosaur coming out right now. Little TIE fighter. Yeah. So, this is good stuff. Seeing if I can pull up a feed from my printer right now. Oh, yeah, I'm in the wrong range, so that would definitely help. So I recall it was on like 14. about it. Yeah, when I take a break, I'll go out and see where it is, but I want to keep continuing on this. So, another thing here. So now we'll make the actual mesh itself. So that's going to be a similar mesh, but we're going to go a little bit bigger. We're going to add 2 on each side, so that makes this a 36. For this piece to print, well, the octopus that's printing right now, I can pull that up and show you. Is this guy right here, but without the without the hat, Britopus. That's hilarious. Octopus. So the one that I have going right now, oh nice, that should be a remix of, there it is, Cute Mini Octopus. I've got one of these guys coming out. That's what it looks like, and it's gonna take about 2 hours. So I anticipate that the print that I got going right now will probably take about 2 hours as well. It's about the same size. Maybe a little bit less because it doesn't have as many little intricate pieces. So when the 3D printer prints these, it has to like look at it from the side and slice it into very thin layers. And depending on the type of printer I use, one of them uses a spool of filament and the other uses a vat of resin. So that is that's how that works. Alright. So we've got this guy, we'll move him up 10. He's got the right radius. And then we're going to grab the roof on him. Raise the roof! We're going to grab it and we're going to move it in the Z-axis by 3. So what I did was just lift this guy up so that it's taller than the other one. Woo woo. It's also bigger than the other one, so we're going to do kind of the same thing to the bottom punch. We're going to grab the bottom face of it, and we're going to grab it and move it down in the Z1. So that pulls the punch so that it's outside and easy for these two things to intersect. Oh, hours, yeah. So it depends on the thing. If I print it in the resin printer, it probably would take like 4 hours. The resin printer, it just depends on the height. And I might end up printing an octopus in the resin printer anyways, because I think that'd be cool in there. But this right here, I don't know if I'm going to do it in the resin printer or not. Both printers make great quality prints. The resin one just has like a much higher level of detail. I'll grab some samples here in just a few and pull those out so we can see them. But alright, so we've got this guy. This is going to be our base, and we're going to subtract the punch from it. Super easy, not really complex operations we're doing here. So we're going to use a boolean. We're going to use the punch bottom, and we're going to pull the difference. So now wherever that punch bottom is, it's going to hollow it out from the other guy. Woo woo. Step 1 down. I have this cavity area right here. Yay. Yeah, we're going to get into some funsies because I'm going to have to use a mirror modifier to basically any of the work that I do on this side will get duplicated on this side of the object. So I gotta keep my operations like really slim and to the point. Alright, so I can actually go ahead and just subtract that right away. So we'll apply this, and I'm gonna go check out this model now. So base now has that punch taken out of it. I gotta basically tell it where I want them to connect. So I'm basically just going to give it a little stitch on each one of these axes right here. I could do more, but this is all that's going to be necessary. Yeah, we're doing this whole thing. It's gonna get there. But I don't have to hit each one of those. All I have to do is just hit the ones there. And then now we can add the little wedge that's inside of there. I may actually just do it manually, so it's not that hard. So we're gonna add a cube, teeny little cube. I got the measurements on that, so it's gonna be a 20 by 8 by 15. So we're gonna call it a 20 by 8 by 15. So we'll make this a 1 by 1. Move it up 0.5, 0.5, and 0.5. So we're just make a little 1 by 1's cube here, and then now we're gonna scale it so that its dimensions are 8, 15, and 3. I guess now it's supposed to be 20. 10. 8 and 3. There we go. Now we're looking right. Oh, it was 8 at its widest and 3 at its thinnest. So if I take one of the sides and scale it in the x direction by 1.2, no, 2.2, that would make not quite enough. So what do we need to get from 3 to 8? 8 divided by 3. 2.6. So we're going to scale that in the x direction by 2.6. And now we have our 8. So now I have my tooth. And we can just slide this tooth right into place. So we're just going to grab it, move it in the x direction, the y direction. Right over there. And then we'll move it in the GX, and we'll go over 5? Yeah, 5 seems about right. 4? Yeah, 4. And we'll rotate around in the Z so that it is lined up in the right direction. This is looking right. GX. Alright. So now we're just going to move this ever so slightly down in the Z, or excuse me, up in the Z by 0.1 or 0.001. Here we go. Ever so slightly, like just enough for it to, I guess, no, the proper way to do this is to leave it where it is, and then we're going to grab this top face. And we're going to move it G and Z 0.001. There we go. Now that face is properly in there. They just have to be intersecting. You can see how they're like overlapping right there. As long as they're intersecting, then it will go as it's supposed to. And for this one, I'm going to grab this top face and GZ 0.0001. So it's still very, very close, but just enough to where it's going to be under this ledge right here. It's very slight. Very, very slight. Alright. And then now this tooth can be duplicated and rotated. Minus 180. D. And then we can move it in the Y. 6, so we could just put this to a negative, and then we could put this to a negative, and we've successfully added and rotated that tooth. So now both of those tooth pieces are ready to be added to the base. This would be a good time to save, so I'm going to go ahead and yeah, we can go ahead and just save this. Fridge. Alright, we're looking good. Alright, so we're going to go ahead and hide those two guys. We are going to be now adding a boolean to the base, and we're going to add cube, sure, and we're going to do a union. Boom! There it is. We're going to apply that. We'll stitch them in just a second. Let's go ahead and apply get the other one in there. So we'll do a boolean, cube 1, union, and boom. We got both of them teethies. Now they are kind of rounded, so I'll soften them up just a bit, but at least they're the right shape and they're in the right position. You know, it's not exact. Like, I don't know exactly where they're supposed to be, but this is going to be good enough for government work. So that looks about right. If I can hold it properly. I would say that's looking pretty right. So we'll go ahead and apply that. And so now both of those are in there, so we'll get the knife out. Get these faces made up properly. So if I just grab that face and move it, you can see it's attached, but it's like kind of attached. We need to go back and reattach these. Let's look at what's going on over here. If we see it in wireframe, you can see, there we go. That's what we want. We want that area chipped off, just like that. So now that's done proper. Hit apply. We'll do the same thing for cube 1. So we'll go over. That doesn't look right. Oh, it's because it's a difference. We want a union. Alright, that's looking right. Yeah. And so we'll line that and get it added. It's hard to pull a Biden for a second there. The swirly part's easy. No, the swirly part's gonna be probably the hardest part about it. I also have these little teeth to add in the back for support to the swirly part. That's gonna be the most challenging, just getting that swoop. But we're gonna find out how to do that. I think I got a twist modifier or like some sort of like swoop bend. I feel like I'm just gonna build it straight and then we're gonna translate it around in a circle. I mean, I have like methods on how I can do it. I can use what's called soft selection to basically select the post as it's straight and then start at the top with like absolute selection, and then at the bottom is like minimal selection. And as I translate, or in this case rotate around the z-axis, so when I rotate from straight above it right here to over here, it's going to affect these ones most, and then linearly towards the base it's going to not affect those ones as much. So it'll basically just like create that same swoop turn. So it'll go like from straight to like that. Be like some magic. We gonna make it happen. It ain't gonna be perfect. It's just for ice. Like, you know, it's just something to do. Nobody's made it yet, so I figure I might be helping somebody else out along the way that may have had this similar issue. It's usually the motive with 3D printing is that you feel like you're helping someone somewhere else. Alright, so now that these parts are joined, I am going to want to return this surface up to the proper level. I'm not going to care about the overlapping face that's between these two here. Doesn't bother me. It's too teeny. So what I'm going to do is just select that face there, grab it in the Z, and we're going to turn on snapping to vertices. Move it in the Z. So now it's just locked to that axis, and we're going to snap it to that vert just next to it. So we're moving up globally that point 0, 0, 0, 1, highlighted in the top corner here. Same one that I moved it down a second ago. All these like very specific things, because if I didn't do that, it would like print that gap between there. Like you could see it just barely. If I turn off, it's like a sliver, the smallest sliver, but it is there. 0.00, there it is. Look at that, we found it. That is what 0.0001 looks like. Not even. So we're gonna do the same thing. We're gonna grab this in the Z axis, just moving it up and down. It's kind of like music bars. And we're gonna snap it to that vert. I'm meandering, I'm sorry. Alright. This is a good song, by the way. Good one. Alright. So now we can I'm done being upside down now. So we've got the inside modeled, so now we need to add this disc around the perimeter and then start working on the top. We're getting somewhere. So the next thing is the disc. So we're gonna add another cylinder, and we said that that's gonna be 9. So if we had 72 as our outer diameter, we've got to add 9. Then the radius is gonna be 1 divided by 2, 40.5, and then our depth is gonna be 3, and I do know the height for that is gonna be 7 plus 1.5, so 8.5. So there it is already in place. I'm gonna need to subtract first the inside of this so I can use my punch to pull away the inside piece from this. So I can scale up my punch just a little bit. So like 1.2 and 1.2. Oops. Excuse me, 1.1. Oh, it was a little too big. 1.01. So I was just making it just a little bit bigger than the inside. It can overlap. So what I'm doing is I'm cutting the inside of it so that when it adds it, it's not adding the centerpiece. So the first thing I'll do is grab the new cylinder, add a modifier, a boolean, take the punch out, apply that. It's done. Now we're going to hide the cylinder. This is going to be our, what do we call this? I don't even know what to name it. The PC build worked out really well. It's running everything right now. The PC is mining Bitcoin right now in the background. I've got two 2070s inside of it, and yeah, no, it's doing the thing. Ended up coming back and adding a water cooler to it at one point. I've got videos posted of that. Yeah, we'll just continue to call it cylinder. That's fine. So, and we'll add the cylinder to the base. We're doing a union. So that's gonna add it on there. So that doesn't look right though. That looks a lot more thin and not a lot more wide than it is. It don't seem right. Oh, that's why, because I only added 9, not another 9. I wonder if I could just scale it. So if I add 81 was, oh, I could just scale this to 90. So 90, there we go. I can modify the inside. Yeah, it's doing some heavy work. Right now it's crunching like 32 mega hash in the background. Since I'm streaming and, you know, working in Blender, I paused the mining on the main card. So, you know, that way my computer isn't like lagging out. But most of the time when I'm just internet browsing, I can keep both cards mining. I usually get about 72 to 74 mega hash per hour, or per second. Not per hour, that'd be terrible. Yeah, mega hash per second. And that nets me like $8 a day in crypto, and Bitcoin. So every week I get about $60, and then $60 or $70, and I reinvest that in a new coin or another coin that looks attractive at the time. And so far I've invested about $1,000 and made about $600. So, but I don't plan on pulling any of it out. I'm gonna let it grow. Just let it do what it does. Alright, so the cylinder's still being added. Cylinder's hidden right now. We need to decrease the interior ring. So we're going to scale that down to like here. It was just a guess on where. How close did I get? Oh, wow. So I was close, but not close enough. There we go. All I just wanted to do was just bring it to where it's inside of the object. So I need to scale in just the Z alone. Yeah, I mean, eventually I'll be able to pull my initial investment out. My initial investment was at one point like $500, and then recently I dropped another 400 in just because it felt right. Felt like the right time. So, alright, now that's looking more like the actual object. And again, it has some rounded corners. I'll deal with those in just a little bit. So, right now we're looking at the bottom side of this guy. Yeah. But I do plan on using my modeling skills for helping out like streamers and stuff. I know I've had some requests recently for like arenas and like you know, some certain stuff to be made, so I will be working on that. I'll likely do it here on the stream because why not? I was thinking about creating a whole other channel for it and everything, but I was like, might as well. I mean, I game on here, same person, same persona, so might as well do it. Alright, so that's added in there. I think geometry should look good enough. Again, I will need to stitch some of this in. Let's grab that knife. There we go, that one's already in there. Let's get this one. This is a little housekeeping that, like, if I didn't do these little steps right here, it could cause some big problems for me down the road. See, it already knew to do some of it, but I'd like to go the extra mile and make sure all four corners are there. Make you forks? Yeah, if you want PUBG, I'll print you out some forks. I know I can make. I have food safe materials. There, it's what's called PETG. PETG stands for polyethylene tetrapethylane tape. That one, PTFE. It's similar to polytetrafluoroethylene, which is what is on the bottom of the mice. That's like the anti-skid, anti-scratch, smooth plastic that doesn't wear down. Sort of like that, but PETG is just a glycol, you know. So it's the same stuff that like water bottles are made out of. But it's food safe, and I can print with that, and you could have a fork. Stick a fork in it. Alright, so that piece is good. Where are the damn forks? Like, that's a thing. You tell her, what the fork, Mom? Just don't say fork you, because that's not right. Alright, so next is going to be the shaft going up the center. I've got a total diameter for that is 13.5. Interior diameter is going to be 7.5. So I've got 2 cylinders to make here. Let's go ahead and do them. So we got cylinder radius. It's going to be 13.5 divided by 2. The depth, or in our case the height, is going to be a stocky 56. And our location is going to be a little complicated. 56 divided by 2 is going to be what? 28. Yeah, okay. Plus the height of the original cylinder, which was going to be 20 plus 3, 23. So 28 plus 23 should put that right on top of it. Hey, that's right on top if I've ever seen it myself. This is how you know if it's done right. If you see it doing that little flicker thing, just like that, that's how it's done right. Plastic ice cubes. Oh yeah, that would be a way to go. I don't know how well they would stay cold, but I know I've seen the ones that are like filled, and I got a relative that always has the light up ice cubes in his martini glass, just every time. It's okay, it's good stuff. Again, as before, we are going to need to grab that intersecting face down here, just because 3D programs don't really like it when things intersect like this. They don't know what to do. They're like, hey, is it up, is it down? So by moving it down just a fraction, 0.0001, it just tells it, hey, for sure, this is on the inside there. Such a 5-light cube. Yeah, of course. And this cylinder in the center here is way higher detail than it needs to be, but whatever. Alright, so now we need another cylinder to punch a hole in this one. So we're going to add another mesh. Cylinder. Instead of 6.5, we're going to do 7.5 divided by 2. For this one, I am still going to need this to be a specific height because I need to know what it is and where it's at. We're going to do the same height. So we had 23 plus, what was the half of 56? 28. 51, so we put it in the same spot, and then I'm just going to do exactly the opposite, is just grab that top face, G, and this one, I don't care how far we lift it up, just as long as it's poked through the top so that there's a hole. And then the bottom face, we are still going to have to grab, and I want to move that one up GZ3. Right? Is that how far that's up? No, it's up 4. Glad I checked. You can just see it like with the cutaway piece, like that center post is just a little bit higher. Suddenly blinded. So yeah. so now top, punch top, and cylinder 001 is going to be shaft. And so right now we're just dealing with the shaft, and we're going to take the punch out of it. So Boolean punch top. Put the Boolean on the right thing, punch top, and we'll hide it so that we can see it, go into wireframe so we can tell what it's doing, and that looks like it's doing it the right way. Sometimes the Booleans just do it right the first time, you get lucky. Again, this is way higher resolution than it needs to be, but whatever. Alright, and then the last thing I needed to do was add the little notch that's inside there. It's about 13 down. Is that the right measurement for that? About 15 down. So if it was 56 tall and it's coming down 15, it's at 41. So how can we get to 41? So right now I'm just going to make a reference cube. We're going to make that 40 tall. We'll just do it that way, and then we'll call it the same 23 plus 20 plus 4. Oh, I added a plane, really? Of all things, 180. Yeah, that's fine. Yeah, that works. 47 minus 3. So that just tells me about how high I need it. If I delete it by accident, yeah. All this work for nothing. That does happen, believe it or not, more often than not. I save often. Alright, so we'll go ahead and edit this object, and I always forget the name of this tool, so I just have to go in here and look for it. I need to, it's sort of like the knife, it's like cutting a line around. Loop, cut, and slide, Control R. Jeez, I always forget that. Again, this doesn't have to be exact, it's really just general mark of where it needs to be. Alright. And I didn't even cut it on the right surface. There we go. Okay. So first thing we need to do is grab this guy, apply that modifier to him, and then now go into edit mode. We're going to bisect the proper face. Go into ISO view and Control R now that I remember it. Yep, there we go. That's good enough for government work. And now we just need to flatten 2 little sides in there. I guess it doesn't really matter what sides we flatten. So we just need to do another Control R. Just do it to like right above it. And then we grab some faces and flatten them. go back into shaded mode so we can see what's going on in here. And we're just gonna grab an arbitrary number of faces here. Face mode. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That seems right. Alright, we're going to scale those in the Y to 0. That's going to flatten them. And then we're going to grab them and move them in the Z, or in the Y again, just until they're out and lined up. Except I keyed the wrong part of it, so I did the right action. So scale, Y0, grab Y, and move to there. So there's my notch. I'm just guessing that that's going to be the right, that just looks right. So based on that there, I'll show you what we're dealing with. This camera should focus. Oh wait, no, I have it on manual focus. Hang on, wait for it. Wait for it. No, not filters. Properties. Configure video. Why did it pop under like that? There we go. Focus. Alright. I should get better at this. Dirty hands. I don't know, does that look right? Could it be bigger? Yeah, maybe it could be. Yeah, we'll say it's gonna be bigger. I'll leave my camera blurry for a minute here. So we'll see if that seems right. I mean, this is a pretty important part of it right here. So it's the ice dispenser in my fridge. See, now I feel like I grabbed a little too much. Yeah. There we go. I'm gonna go with that. And we'll say that that's going to be the one. About how wide we going? Oh, I know how to do this quickly. Okay. So we'll go here. Turn on X-ray mode. There we go. And that one. Alright, scale Y0, GY. May have gone one bigger on the other side, but so little nudges for the metal bar that holds. I got you now. Sorry. There's a metal bar in here that twists that also has blurry. Focus. Alright, so there's a metal bar that goes inside of here, and the metal bar twists as well, and it also has teeth that spin and push the ice. I think this one in the back here is just like meant to like keep it spinning along the back. But this area in the back here has like big teeth that hook onto this. So when the teeth spin, this whole thing spins and ice comes out. Right now, we have to open the fridge and put our hand in to pull the ice out. So we're trying to remedy that. That's the goal. So yeah, we'll call that good for the inside. I can see it's like, I think it's one or maybe two small on this side, but maybe that'll give me the room that I need. So I can always shave it down later. We'll call that good there. Save that up. So our shaft's looking nice. We can get rid of this plane out of here. Yeah, those notches look right. Yeah. I mean, that's the real test right there, is just look at it. Yeah, those are right. It just makes noise. That's great. Oh, sorry for your fridge struggles. It's not every day that fridges don't chill out. Oh. Yeah, some things just be coming on you like that. I had some, I was eating Sloppy Joe's the other day, and I looked down at my plate, and you know, sometimes you take pictures of your food before you eat it, but I just had to stop and tell my food to like back up with all that, because like, you know, that's a whole lot for a sandwich to be putting out there. Like, what you gonna do with it? We're at 1 hour. I only got the hard task left to do. So let's add the shaft to the base. So we'll do the base, Boolean, shaft. Or I guess I'll add that all at once. Is that you in the corner? Probably. Yeah, that was a restream of me. I have my phone out as a viewer, you know, keep the viewer count up off of 0. And also to make sure that my stream is going properly and sound's coming through, not crackly or messed up. all the things. Alright, so I'm going to hold off on adding it to that first. I'd like to start working on the twirl. So we've got some dimensions for this. I've got like a triangle at the base that goes from 25 down to 4. and then it stays 4 wide all the way to the tip, and then from the tip out it goes to 12. So we've got the base that starts at 25, it goes into 4, and that's how wide the whole thing is. And then up at here at the top, so it starts at 12 and then tapers down to 4. Nope, just doing the thing. Alright, so we'll make this at, again, 1, and we'll just put it out here at 20 everything. I can see it. There it is. Do 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 do. Boink, boop, 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 boop. Cube. Alright, so measurements are gonna be 25 and 8, 6, yeah, and we said it was 12 tall. So we're dealing with the outside wedge here. It's just kind of, alright, so this top piece is only 4 wide. So if I'm going from 25 down to 4, is 0.16. So scale in the X direction, 0.16 makes that 4. And I overestimated on the thickness. So I'm just gonna grab this and slide that into how thick it looks. Just looking at like how thick this little triangle piece is. Again, I'm gonna start with it flat and then I'm gonna push it out so that it fits that shape. I'll start with it like this and then I'll flex it out to match the extra. Alright, and then we'll extrude this guy without snapping on. Straight up. And how long would we say that's going to be? If that was already 12 tall, and we said that the height of that was 13, 56 minus 13 is going to be 43, minus 12, 43 is going to be 31 tall. So we just need a 31. It's not big, I mean, it's math, but it's really just like addition and subtraction. For me, like, I just was counting in the height of this and subtracting this right here. So I used the total height of this minus that distance minus that distance. So it's really just like quick head memory math. I could sit and write it down too, but there's like a performance to you know, doing it right, and something looks a little off with this guy. Yep, it is. It do be just a little off. What did I did? You know what? I'm just gonna let it be. Oh, there it is. Yeah, that was the action. So when I moved this out, I moved it like that. Gotta lock to the axes. So G, Y, and there we go. So, and then 31. G and the Z axis, 31. Whoops, I gotta extrude first. E, Z, 31. E, Z, see? It's easy. And we said it's 4 at its greatest thickness, and then we can extrude in the Y direction. GY2 minus. We'll scale this one down just a little bit. Scale 0.8 in just the x-axis. And then this one, I'm going to grab just the vertices and scale those, just eyeball scale. Because the base does seem like a little bit wider, but not like super wide. I wonder if it'll snap to these. Oh, I guess I can translate them. So if I do G X there, G X there, now they're exactly the same. Alright, so now we'll grab these faces and extrude them all the way inside of here. Doesn't matter how, well, as long as they're not poking through there. Yep, so as long as they're through, now they're in there. We can also move this whole structure back over to exactly equal 0. We're getting there. These faces can go out, so G and the X, and the Y actually, 1. Alright. And then we said at the top it's got like this extra little lip for support. So we'll add that in there. Control R. And we'll just add that at the same thickness that it is up there. And so that's going to be an extrusion on this part. E in the Z direction. And there. Y. And I'll probably just grab this edge here and move it. And I can tell it to ignore 2 axes if I wanted it just to snap to like exactly to one of these. So go, we said it was pretty much the outside angle, so go to there. Still not intersecting, shouldn't pose any issues. So now it's got that little extra lip. Now we can set the origin on this. So the origin is going to be like where it rotates and everything from. 3D cursor, set the origin is at 0, 0, 0. And I'm actually going to set it up to 23. So now we have the origin is there. And we're going to set the origin of the object to the 3D cursor. And so now when we do a rotation action, it rotates around the right spot. Right? We're getting somewhere, man. Takes a little bit of time, but go ahead and slide these guys in so that they fit right there. See how everything just like pops right to the right spot? Like put one on here, do another one, and there. these. Yeah, I mean that's close enough for what we're looking for. Again, it doesn't have to be perfect, it's just enough to do what we're looking for. So right now it's just making that shape right there. And then we'll start doing the twist. So I could do the twist manually. Basically all I have to do is select everything here at the top. Including the things not seen. So right now it would be helpful if the shaft was out of the way. There we go. Now I can see I'm selecting everything. We're going to rotate from, instead of the local, we'll rotate from the cursor. RZ. So it's going from the object center, so I need it to use 3D cursor. There we go. So R, Z, so now we have it rotating. RZ, so we can see we can get that bend. We just need it to have like a smooth bend rather than like a sharp, doesn't know what to do with this center area fat kind of structure thing. So we need to add some geometry. I think that's enough geometry. So that looks about right. So again, we just need to select this area up here. Including things not seen. And then we need to turn on soft select, proportional editing. And we're gonna do a linear, I guess, or sphere or smooth. Let's try smooth and see. So G, we're gonna RZ, so we've got that. So we're seeing it start to affect. You could see the one on the left side there starting to move. Proportional editing radius. So I've got to check and look up something real quick. Proportional editing radius. Okay, so like I feel like it's increasing, but it's just not showing. Normally there's like a little indicator. Nice, we got face measurements and everything. That's really dope. Well, thank you for stopping by, PUBG. I appreciate you. Yeah, no, I'm almost done here. Thank you. I appreciate the support and stopping by. I really, really do appreciate that. So, thank you for sticking around. And almost done here. Just have to figure out how to use the proportional editor again, and then we'll be able to go. Appreciate the luck. There we go. So my proportional influence was just like really, really small. Okay, so now I've got it. RZ. Look at that. He was like, you were moments away from seeing it happen. Oh, sad face. Oh well. G, Y. G. So how far does it stick out? Last untaken measurement. So it sticks out 10. typically goes like 40 degrees. So R, Z. So yeah, I wouldn't have that. It's more of like If we C, Control V. We'll call arm 1, arm 2. Cool, arm 2, we're gonna rotate RZ 180. To make sure that all intersects the shaft. Doesn't come through the center. Already moved our faces below. I don't remember if I did that or not, so I might as well do it again. Hide the base. Grab face, 2, 3. And G, Z minus 0.001. Z minus 0.0001. So those two are completely inside. And I'm not going to do the lateral supports on the back. I don't think it needs it. That shouldn't need it. Oh, I did forget about the back arm. Again, I think it's going to be strong enough. Alright, so we'll call this prototype number 1. About that, you know, what, 2-hour mark, something like that, coming up on it. Hour and a half. Yeah. So, let's get this finished up. So we'll attach these two to the shaft. Let's Control C, Control V the shaft. So we've got to back up one of it. We're going to add the arms. Boolean, union, arm 1. Make sure everything looks right in wireframe. So shaft. It doesn't seem to be super happy with it. Let's try it. Let's see what happens. Boolean arm 2. That one added a little happier. Okay, so the reason it didn't add happy is because it had unsolved booleans from the first time. So this is why I usually do that prep. So we'll go to the shaft, knife it out. Alright, so let's try that again. maybe I do it the other way around, is add the shaft to arm 1. Hey, that's right. Apply that. So arm 1 got applied to it. So now we'll do it the other way. Control C. Control V for an arm 2. So I've got a copy of it. And then we'll add arm 1. That looks right. Alright, and we'll zero that. And apply that. So arm 2 is now the official arm. Arm and shaft. Top. So we'll add the top to the base. I've already pulled that face down just a little bit, so all of that should line up. And base. This is looking right. What I think I could have done was maybe like brought this face out over more. That was definitely on the original design. But I'm not too concerned about it. We'll see how this one does. If I need to, I'll add it. So we'll add this to the base. Yep, that looks right. So before I do it, make a duplicate of it. Marry them up. We have our final piece. Hooray. Alright, so it is about print time. My 2 hour mark for the print that's on there now is completing. So here is what I've built. You could take a look at it real quick. So I didn't include everything on it. You know, just most of what was necessary to get it across. I think I got the swoop pretty good. I mean, it obviously has like a bowl to it and everything on this one, but I think it'll do. Alright, well, let's do a thumbnail. Yeah. Clean it there just a little bit. Do this. I can do this.
Everybody know I got pound. Get down. Talking, got pound.
Yay, okay, that took long enough. I'm happy with it. Ah, very cool. Alright, save, export, and send it over to the printer. Non-resin. Call this the fridge. Just the selection only. And yeah, I'll just save it as is. Boom. Well, thank you all for joining. I appreciate you stopping by. This is a different stream. If you like what you saw, give me that like. Let me know what you liked it. If you like something specific, say it in the comments. Let everybody know. You know, I like doing this, so I hope you like me doing it too. If you do like me doing it, then go ahead and click the subscribe button or get followed, or you know, whatever platform you're on. Do the thing so that you know when I do my thing. Go help each other. So take it easy. I'll see y'all tomorrow.